Okay, so the next figure we're going to look at is a rhombus. So a rhombus is just a special type of a parallelogram, right? So as we discussed previously, a parallelogram is a quadrilateral where the opposite sides are parallel. Right? So the rhombus is a parallelogram, so that holds. The opposite sides are parallel, but it has the additional property that all sides are equal. Okay. All right. So here, all right. So we'll have opposite sides parallel, and then all sides are of the same length. All right. So the angles diagonally across from each other are of the same measure. Okay. So that is the only difference between a rhombus and a parallelogram. Right, so we could use the same formula that we had for the area. The area is 1/2 base times height, so that would still be valid, where the height would be from one of the corners, dropping a perpendicular to an opposite side, right, and that would be the h. Right, but as it turns out, the rhombus does have its own kind of special property. So there is actually another way that the formula, that the area could be calculated. Right, so some other properties of a rhombus. So for one, again, think of a rhombus like analog to the square. Right? As a square is to the rectangle, the rhombus is to the parallelogram, right? Just kind of a square that's kind of been leaned on, right? It's just kind of leaning over a bit. Okay, so aside from the opposite sides being parallel and all the same sides, if we were to take if we assume this is a rhombus, so it has all the properties that I just discussed here. Some other properties that arise when we take these diagonals here from the two corners here. What happens is, in doing this, if we have a rhombus, all of these angles where the diagonals meet, those are all right angles. Right, and not only that, that they bisect these diagonals here. So these lengths here, right, if we right, so those are all those are all equal. So, and also that means that these diagonals bisect these angles, right? So this angle, same as this angle, and then across the diagonal one here. Those are all the same, and these are the same measure as the one opposite the diagonal here. Okay, so some interesting properties occur here when we do have a rhombus, right? So as it turns out, using kind of area formula for these little triangles themselves, the rhombus also has another formula besides the parallelogram formula. So the area of a rhombus can be calculated by the formula 1/2 d1 d2, where these values d1 d2 are the lengths of the diagonals. Right, so if this is a rhombus here, we can call this the first diagonal. So this would be d1, right, this length. And then the second diagonal would be this one here. And it's d2. Okay, so that's another formula that we can use to calculate the area of this rhombus.